Okay, so here's the calorimetry sample. So there's the problem. We've already read it to you guys. The calorimeter contains 63 grams of water at 34.5 degrees Celsius. A block of copper weighing 150 grams is heated to 123.0 degrees Celsius. The copper sample is then quickly transferred to the water in the calorimeter. The temperature of the water in the calorimeter rises to 39.0 degrees Celsius. Calculate the specific heat of copper. Here is my equation I'm going to use. Remember, it's the mass of the water times the temperature change of the water times the specific heat of the water, set equal to the same information of the metal except the negative of it. So it's the negative of the mass of the metal, the temperature change of the metal, and the CP of the metal. X stands for metal, okay, so we can keep it clear. Now all you do is read and start to fill in the blanks. The calorimeter contains 63.0 grams of water, so I know that that's 63.0 grams of water. It says it's at 34.5 degrees Celsius. That doesn't help me much yet, so I'm just going to skip that. A block of copper weighing 150 grams is heated to 123. So here's the mass of copper, 150 grams. And it says it's heated to 123 degrees Celsius. When they tell you what the sample is heated to, it's not in the water yet, so that's what it starts at. So in this case, this would be minus 123 degrees Celsius. Okay. Let's continue reading. The copper sample is then quickly transferred to the water in the calorimeter. The temperature of the water in the calorimeter rises to 39.0. Okay. The final temperature of the calorimeter, which in this case is 39.0, is also the final temperature of the metal because they're together. So that means up here where it says the calorimeter contains 63 grams of water at 34.5, that's the starting temperature of the water. Okay, usually when they word it like that, the grams of water at a certain temperature, that's what it starts at. When they mention that the block of metal was heated to some degree, that's what the metal starts at. But in the end, they both end at the same temperature because they're combined in the calorimeter. Okay? I know the specific heat of water, it's 4.184 joules per gram degree Celsius. Be careful of that. They don't tell you that. But look, it's a calorimeter and it's working with water. So if it's water, you know that. And in our stuff, we always use water. So the CP of water is always 4.184 joules per gram degree Celsius. But they don't tell you that. You have to remember. Okay, continuing. And the other piece of information that's missing is what they ask for. They ask, what is the specific heat of copper? So that is my unknown. Okay, so that's my question mark. All right, so I keep going now. Here's my equation, and now I'm going to isolate my unknown so I can solve for it. Like so, and I know I'm solving for this. And on these problems, since they're linear and it's just multiplying, when you're isolating the unknown variable, just simply take everything that's left with it on its side and divide it to the other side. So here's what I want by itself. Here's everything that's on that side as well. So I divide all of it away. And I can do that as long as I do the same to both sides. So there's the same, like so. When I do that, the negatives cancel, those cancel, those cancel. And I've isolated now CPX by itself. So now I rewrite it. CPX, and again, I just rewrite it because I like it on the left side. Mass of water, delta T of the water, CP of the water, divided by the negative mass of the metal over temperature change of the metal. Finally, my favorite step, step 3, the plug and chug, because now all you do is just put in the information in. Okay, the mass of the water was 63.0 grams. The temperature change of the water, we did not calculate it yet. 39.0 minus 34.5. We'll do that in the calculator so you can see it. Remember, since there's one decimal in both, the final answer will have one. 3.6 degrees Celsius there. Okay, I filled it in right there. And then this one, 39. The water temperature change always goes up. The water gets heated, so that should always be positive. If it's not, you did something wrong. The other one, the metal always loses. 39 minus 123, and you get minus 84 0.0 degrees Celsius because they both have 1 decimal, so that's how that works. Okay, so now I have everything. So the temperature change of the water, 3.6 degrees Celsius. The CP, the specific heat of the water, 4.184 joules. And then on the bottom is grams per degree Celsius. And then over here, the mass of the metal, 63, not 63, whoops, metal is 150. 150.0 grams times the temperature change of the metal, which is negative 84.0 degrees Celsius. So that's what my setup looks like. Okay? So here we go. So it's 63. On the top, it's 63 times 3.6 times 4.184. And I hit equals. Okay, and I get that number. And I hit divided by. Open parentheses, because you're multiplying these two together. 150 times negative 84, close parentheses, equals, and I get this number. Okay? And remember, we also have this negative out there. I forgot to put that part. The negative and this negative, so that's going to cancel it out. Okay, here's my final answer. So I get 0.07. Let me do that again because I forgot to put the negative so you guys see I didn't do nothing. So look at the screen again, okay? 63 times 3.6 times 4.184, and I hit equals. Okay? And I hit divided by, and then I hit parentheses. I put that negative sign. It doesn't matter. Just put it right there, just before the first number. Times negative 84, close parentheses. And I get the same number, but notice it's not, you can't have a negative specific heat capacity, okay? But there's the number, 0.075312. Now look at the units. Grams cancels with grams. Degrees Celsius cancels with this degrees Celsius. I forgot to add the C there. Okay? And the unit left over is joules per gram degrees Celsius, which is the unit of specific heat. So that looks good. And now significant figure time. Okay, that's the last thing to do. 3 sig figs, 2 sig figs, disregard 3 sig figs, 3 sig figs. So I'm going to go with 2 sig figs. So my cutoff is right there. Okay. 0.075 joules per gram degree Celsius is a great final answer for this calorimetry problem.